Before I get started on number 19, I want to emphasize, with a little note here I'll slide in, that I have, let's say, more detailed point-by-point descriptions of how you factor already posted on YouTube. So if I'm skipping over things you don't understand or I'm going a little too fast for you, please refer to possibly review GCF, factoring out the greatest common factor, or refer to factoring, review of factoring trinomials with leading coefficient of 1. A lot of times I'll say nothing in front. And also if you need some help with the box method or factor by grouping, any of the videos from 11.4, almost all of them show you a way to use both methods. Okay? And we'll take a look at number 19 here. Zoom in a little. And let's see. In fact, I'll zoom in one more. There we go. This one's a little unusual. Usually when I'm going to factor, I'll be referring to these rules. Oh, I have to zoom out again, sorry. One more. Alright, so when I'm factoring, I'm going to be referring to these rules. So if you don't have them written down, you might want them handy. And you need to be able to basically write these down. It shouldn't be very difficult to memorize unless you're pretty good with this and you just have these ideas in your head. Okay, but I'll be doing things in this order each time. And zoom back in. And I will go one. I hope you can see that. Alright. Now, on my list of 4 things to think about for factoring, I didn't actually address this situation, so some things perhaps you just kind of need to have in your mind. If you want to write them on the list, that's fine, but I try to have the list as bare bones as possible. Okay? If it's too detailed, it's just not much use to you. Notice it starts out with an x to the first power instead of x squared, which is how most of the problems you've been solving started out. If that's the case, basically it's standard practice in math to arrange polynomials in descending order. So I'm going to rewrite this as x squared. That's not a very good x squared. Let's try this. X squared. That's positive 7x, so plus 7x and negative 30. Okay, so all I did was rearrange these terms in descending order. And now if there's nothing in front of the x, I just grab my 30 and list all the factors. And that would be 1 times 30, 2 times 15, 3 times 10, 4 won't work because that's an odd number, 5 works, 5 times 6, and that's all the factors. We're looking for a difference of positive 7. By the way, I pointed that and said difference because the only way you can get a negative 30, if you're, and this term is a result of multiplication, you would have to have positive times negative or negative times positive. When you turn your attention to the middle, you're going to be adding or subtracting, and in this case the signs will be different, so you'll be subtracting. Anyway, to get positive 7, you would need positive 10, negative 3. That's the only one that'll work. So you have the second term of each of these sets of parentheses ready to go. For x squared, it would just be x and x. To get a negative 30 and also a middle term of 7x, you'll have negative 3 and positive 10. Again, there's more detailed explanation of how you get there already posted on YouTube. And let's take a look at number 20. Require another sheet. Excuse me a moment here. here we go. So number 20. This one just looks a little unusual. That's why I decided to do it. And let's get some paper in line here. All right, there's nothing in front of the first term, so you just grab the last term and list all the factors. There aren't many factors. 1 is 1 times 1, and there's no other factors. If this is positive, that means I got there multiplying either a positive times a positive or negative times a negative. And if this is negative, I must have used negative times negative. So the factored form is simply going to be a z in the first term here, and minus 1, minus 1. Okay, notice there's another way we can write that. Since we wrote the exact same thing twice, we could just write z minus 1, the quantity, squared. All right. This indicates there's 2 sets of parentheses with the exact same thing inside. In fact, this is referred to as a perfect square trinomial. If you can get where you recognize them, it tends to save you some work, especially on the larger number values. All right, let's see, number 21. This one looks a little different. Because you have x to the 4th. Okay. We'll start out basically the same way, though. There's nothing in front of x. Well, usually I say x squared, but there's nothing in front of the first term other than a 1. So you just grab your 63 and list all the factors. So that would be 1 times 63. That always works. 2 won't work. 3 goes in there 21 times. 4 won't work. 5 won't work. 6 won't work. 7 times 9, that works just fine. And this is all the factors of 63. All right, I'm looking for a difference of negative 2. So if I had a negative 9 and a positive 7, that would give me a difference of negative 2. So we're ready to show the factored form of this now. And what's a little unusual is usually this first term is x squared, so you simply put an x here and an x here. But if it's x to the 4th, I'm going to need an x squared here and an x squared here, because x squared times x squared is x to the 4th. Okay? And then I have a positive 7 and I have a negative 9. Okay? For number 23 here, you're going to have to notice that the exponents are not arranged in descending order. X to the 3rd is the highest exponent, so that this term needs to be first. Okay, so we'll start with doing that. So we'll have 3x to the 3rd. The next term would be 3x squared. That's positive 3x squared, so you'll put plus 3x squared. And your last term is your negative 18x. And then referring to the list, I showed this in full frame at the beginning, rules for factoring. I'm going to be referring to that. Number 1 is GCF, and there is a GCF. You can get a 3x out of here, and out of here. So slide this over a little. I'm going to factor out the GCF of 3x from each term. And when I do that, that leaves me with the first term. If I divide by 3x, I'll be left with x squared. For the next term, I'll have just an x. And for the last term, negative 6. Okay? And now there's nothing in front of x squared. You grab the last term, list all the factors, 1 and 6, 2 and 3. I'm looking for a difference of positive 1, so it must be positive 3, negative 2. So the final factored form is going to be 3x. To get your x squared, you're always using an x and an x, and then I have minus 2 and plus 3. Okay, so this is the factored form of your original trinomial. Well, actually the original trinomial is up here, and here we just rearranged it. Okay. Okay, these terms are arranged in descending order. To find the power of the term, you add the exponents of the term. So 3 and 5 would be 8, 7, 6. So you have the highest power first. And then you have to, number 1 on our list is GCF. Is there a GCF? Yes. I can get a 5 out of each term. I can get x to the first power out of each term. And I can get y to the 5th out of each term. So I can factor out a 5x y to the 5th from each term. And perhaps I should have put y to the 5th x, but we'll just go with the way I've written it. Alright, if I factor that out of each term, for the first term I'll be left with just an x squared. Okay. For the next term I'll be left with 2x, and for our last term I'll be left with negative 8. Okay, and then you proceed down the list. Again, I referred to this at the beginning of this video, and we have 3 terms with nothing in front of x squared, so we can just grab the last term and list all the factors. So here's our 8. All the factors of 8 are 1 and 8, 2 and 4. Whoops. I have to back out a little here, sorry. There we go. 1 and 8, 2, oh, there's all the factors. So let's see. This indicates we're going to be looking for a difference of positive 2. So it must be a positive 4 and a negative 2. Okay. So the final factored form, maybe I'll start writing it here because this is what we were just working on. For x squared, you'll have an x and an x, and we figured out here that we want a minus 2, a plus 4, and this 5xy to the 5th that we factored out at the beginning, you simply drop it down here. So 5xy to the 5th. So here's the factored form of our original polynomial or trinomial, however you want to refer to it. I have not changed the value in any step. This is the same amount of stuff as this. It's the same amount of stuff as this. Okay? But we want it in factored form. Notice what happened. We had these big high exponents, and now we've gotten down to much smaller ones. First power, first power. All right, we still got a y to the 5th. But factoring is a way to get the power of your exponent lowered. And when we start solving equations, you'll see why that's very helpful. All right, so that's 25. We'll take a look at 26. Number 26. This one's very interesting. Notice in front of the x squared there's a negative sign. We haven't solved ones like that because we don't like them. And here's why. If I have, usually for the x squared, it's not much mystery how you're going to factor it. See if I can zoom in a little on this. I would just put x and x, right? But if I have an x and an x, that won't give me a negative x squared. So this step of the process becomes a little more confusing. So to avoid that confusion, the standard practice is if this first term is negative, simply factor out a negative 1 and then proceed with factoring. So if I factor out a -1, I'll be left with the signs basically will change. So I'll have x squared plus 2x minus 24, and you can always check that in your mind real fast. You just, whatever you've factored out, if I was to send it back in, I would get right back where I started. Okay, so now proceeding down my list, I factored out a GCF, well, sort of. I got rid of the -1. And I have 3 terms with nothing in front of x squared. So I just grabbed the last term, that 24. List all the factors. 1, 24, 2 and 12, 3 and 8, 4 and 6. And there's all the factors of 24. I want a difference of +2. So it must be a +6 and a -4. Okay, so the factored form, you'll have an x in the first position, right? And then -4 and +6. Okay, and don't forget, sitting in front, this -1 is very important because, again, you're not allowed to change the value of what you're given. You can only change the way it looks.